All right, continuing our 2.6 lesson, we're now going to move on to looking at absolute value and piecewise functions. Okay, we've looked at these a little bit before, more so the absolute value ones. Piecewise functions are basically just chunks of functions or chunks of graphs, and we'll look at that when we get there. Now, absolute value functions we've seen in previous courses before. So one thing I want you to write down for these absolute value ones that we've looked at before is all absolute value graphs make a V. Okay, the absolute value ones will make a V shape. Also, kind of a standard form or a form ready for you to plug things in for absolute value functions looks like this. F of x equals an A, you can do capital or lowercase, A times the absolute value of x minus h plus k. Now all three of these things, this a, this h, and this k mean something, but I want you to write down that this is kind of a standard form of an absolute value function. Okay, the first time around that we are looking at how to graph an absolute value function, I'm just going to do kind of our standard plugging values into the table. So again, what an absolute value equation means is take whatever's inside of these absolute value bars and make it just the positive version, or find its distance from 0. So if you were to plug in a 0 for x, the absolute value of 0 is 0. So we'd have this point 0, 0. If you were to plug in 1 right here, the absolute value of 1 is 1. So we would go right here. At the same time, if you plugged in -1, the absolute value of -1 is also 1. So it's going to look like this. Notice, this is not making a straight line. This has to change direction somewhere. Because it's going down right here, it's going up right here. So let's plug in some other points. If you plug in 2 for x, well, the absolute value of 2 is 2. But same thing, if you plug in -2 for x, well, the absolute value of -2 is positive 2. If you plug in 3 for x, absolute value is 3. If you plug in -3 for x, absolute value is still positive 3. You should be able to note or see after a while now the pattern that is being made. On this side, it'll follow, oops, where am I looking? This line right here. And on this side, it'll kind of follow this line right here. This makes our V-shaped graph. This corner, this point is called the vertex, normally starts at 0, 0, and we just go up 1 over 1 in both directions. Okay, kind of moving away this way, makes that V shape. Now, if you didn't like doing the table this way, where it was 0, 0, 1, 1, -1, 1, your table could look something like this. Starting with our lowest values, the -3 makes a 3, -2 makes a 2, -1 makes a 1, 0 makes a 0, 1 makes a 1, 2 makes 2, 3 makes a 3. And you'll be able to see still, working your way down for a little while to 0, and then coming right back up again. So it makes that V-shaped graph. Any absolute value graph will make that V. Now, piecewise functions are technically two different tables or two different lines. You're kind of graphing two different equations, but all on one graph. So, to make sense of that, we're going to look at this equation or this piecewise function, f of x equals. Well, it equals -x if x are the values less than 0. It equals x if x's are the values greater than or equal to 0. So if we were to look at two different tables, this table over here is all of our x's that are less than 0. Okay, so notice all of the x values I picked are less than 0. I also picked exactly 0 and wrote in no or can't do. That one won't work. We can't have x being equal to 0 because it specifically says this only works if x is less than 0. So all of our y values that we're plugging out or getting out right here come from this function. F of x equals -x. So all of the x values, we just take the opposite of them. So the opposite of -1 is 1. The opposite of -2 is 2. Opposite of -3 is 3. Opposite of -4 is 4. -5 is 5. -6 is 6. So that would look something like this. -6 is 6. And 5, 4, 3, 2, and 1. Notice this one does not come all the way into 0. Kind of makes an open spot there because we're not fully going to touch that one. So if we were to fill in this line, it would look something like this. Now technically this line would continue on forever if we didn't say the only where x is less than 0. If we blocked this part out, we would have to keep going and making these dots that go on forever in this direction. Okay, and that's what I mean up here by two different lines. It's this line, this y equals -x, and that's the line that we've graphed here, only in the areas where x is less than 0. So this is open and these would all be filled in. These dots we're actually not using. Okay, so it's kind of a different way to think of it. Two different lines. We're only filling in this line where x is less than 0. Now what would be the other line and where would we fill it in? Well, that would be this table. If x is greater than or equal to 0, we're using this one. We're using f of x equals just straight up x. So notice, I can plug in x is 0 or equal to 0, and I'd get out 0 because this is my function. F of x equals x. If I plug in 1, I get 1. If I plug in 2, I get 2. 3, I get 3, and so on. So those would make the values right here, the blue one, right here, right here, and here, and here, and so on. For every x that we're putting in, we get out the exact same y value. Now notice, that line is going to look something like this, moving out in this direction. Now technically, if we followed this line, f of x equals 0, or f of x equals x, we would also get these points going in this direction. We don't fill in these points, we don't call this a part of our line because we only want this blue line on the spots where x is greater than or equal to 0. So this spot is filled in and it continues on this way. So even though there's two different colors here, there's technically two different lines being graphed, we consider them one continuous graph, one continuous line. And these hit all of our x values then. For every x that's in the negative, we have these red lines or these red dots. Once x becomes 0, we have dots on the blue line that work for it. But technically, all of our x values still have an output or a y value. So this would be the graph of our function. It's this V shape. Notice this V shape looks almost just like this V shape. In fact, it's the exact same thing. So this V shape can actually be either an absolute value graph or it can be from a piecewise function. You just have to show which two different functions it is that makes those two lines. Let's go back to graphing another absolute value one, but this time it's not the regular absolute value. This one does have a little bit of a shift. So again, before, I told you to make note that all absolute value graphs will make a V. This point right here at the V is called the vertex. That's the corner. Okay? Now that vertex, if we can get it into this standard form, A times the absolute value of x minus h, that is all the absolute value, plus the k. Once we get it here, our vertex or our corner is at h and k. Now this a value out in front is both the stretch and tells us the direction. If a is positive, your v is going to look like this. It's going to open kind of upwards. If a is negative, your v is going to look like this and open downward. Okay, so a positive a, upwards, kind of a regular v. Negative a goes downwards like that. Okay, a, the number there, also lets you know what the slope of these two lines are. Remember, looking at this piecewise function, this v kind of came from two different lines, one here and one here. Each of those has its own slope. The slope is going to be a, one of them being a positive value for a, like this blue one. One of them going to be a negative value for a, like this red one. So, looking at our equation, or the function that was given to us, we have f of x equals absolute value of x minus 3. So, notice this a value out here would just be a 1, which means the slope of our lines is going to be 1. We also know it's positive, so it's going to be opening up like this one. As we plug in the rest of our pieces, x minus h, well, we're subtracting 3, so 3 is going to be this spot on our vertex. Now at the end, what are we adding? Technically, we have a plus 0 in the back here. There's this 0 kind of hidden in the back, which means that 0 is going to be the other part of our vertex. So 3, 0, right here is the vertex of our V. Now from there, we know that we're still going to be opening upwards like this, and our slope is going to be 1. So from there we would say go up 1 over 1, up 1 over 1, start making dots like this. Also, go in the opposite direction, up 1 and left 1, up 1, left 1. I guess you would technically say this slope is negative 1, because as we read from left to right, like we normally do, you're going down 1 to the right 1, down 1 to the right 1. With all of these points put together, this will be your graph. Graph of this absolute value is the same as what we had before. Notice I can move this over. It makes the exact same V shape as before. The only difference is it moved over 3 places. And that H value, this little piece inside of the absolute value, lets us know that it moved over some. So if you can remember these transformation properties, A is your stretch and direction, H is the X value of the vertex, and K is the Y value of the vertex. That'll help you draw out these graphs. All right, for our next piecewise function, again, you can think of it as we're doing 2 different lines, or you can think of it as 2 different tables. Now, before even looking at the tables, we're going to ignore that for a little while. I want to think about these 2 functions, one being x minus 1 and one being negative 1. If we are looking at just the graph right here, y equals negative 1. Well, that's going to be this line right here, this constant function, y equals negative 1. Let's look at the other graph. I'm going to do this one in, let's do like an orange color. X minus 1. That y-intercept is going to be negative 1. The slope in front of x is 1, so up 1 over 1. So we'd start at negative 1 and go up 1 over 1, up 1 over 1, up 1 over 1. So that's going to give us a line that looks like this. However, it's going to go on in this direction as well. But this extra piece here says only if x is less than or equal to 3. That's the only time we're going to use the orange one. So right here it's equal to 3, and we want everything less than or equal to that. So we would fill in all of this blue area. This would be our line, or at least our half of the line that goes along right here. However, everywhere where x is greater than 3, we're using our red line, this negative 1. So it would look something like this. We don't include where it's 3, just everywhere above it. So those are the only spots that work. Now that I have my blue line drawn out where we're actually supposed to be, I can take out that orange and red one, and this is what the piecewise function should look like. Now, if I didn't do it that way, if I didn't plot out two lines and decided I'm just going to use my graph, or my table, I would have two different tables. One over here, where x is less than or equal to 3, so 3, 2, 1, 0, -1, -2, -4, numbers like that, and I would have one to go along with each of them. So if I plug in 3 right here, 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is -1. -1 minus 1 is -2. -2 would give us -3. And -4 minus 1 would give us a -5. All of those spots are right here. I'm going to draw those in red this time. One there, one there, one there, one there. Let's see, -1 would be at -2. -2 would be at -3, and -4 would be down here at -5. So all of these red dots come from this table right here. Notice they're all on that blue line that we had already graphed. Now on to this one, I'm going to do these ones in green. For this table, if we try x is 3, remember this only works if it's greater than or equal to 3. So no, we can't have a spot there. That's why this one has an open circle. If we plug in x is 4 though, so a spot where x is bigger than or equal to 3, well, the function tells us that we're looking at f of x equals -1. Remember, that's a constant function. So even though my x got plugged in as 4, my y is -1. My x is 5, my y is still -1. 6, still -1. 7, still -1. It'll always still be -1. So it'll look something like this. So there's two ways to do this. You can either graph both of these lines and say, I'm only going to keep the line in this area and in this area. You can do it that way. Or you can say, I want to make two different tables. One table here that goes along with these x values. One table here that goes along with these x values. And then plug in a different equation to get your y. Either way, you'll plot out the graph that should fit for both of them. The last part we're looking at is just determining whether each graph represents a step function, a constant function, absolute value function, or a piecewise function. So remember, if you get a straight horizontal line going all the way across like this, that one has to be a constant function. It's the only way to do it. Horizontal line makes that constant function. Remember, a step function will actually look like steps. The identity function, which I guess they didn't give us an option here, was that y equals x, goes diagonally perfect through there. Absolute value functions will make a v, and piecewise functions means we're actually using two lines or two different tables. So technically, this example could be either, once it goes away, absolute value or piecewise. Okay, it could be these two lines. I'm going to draw one in blue, like this, and one in red. I know these didn't get exactly on there, but pretty close. It could be these two lines. We're only using the red line over here, and we're only using the blue line over here. So it could be that piecewise function. Or, because it does make a perfect V shape, it could be an absolute value function. So it can be both in that case. Otherwise, that'll wrap it up for 2.6.